Well, students, today we'll discuss a very important concept of vectors, the distance from a point to a line. And we can understand this concept with the help of an example. Example is find the distance of the point Q with the coordinates 1, 2, 3, or 1, comma 2, comma 3 from the straight line with the equation. So you give an equation of the line. So here in the equation of line, we have this part. This part is called the direction vector. This is the direction vector. This vector is the direction vector means a vector which is parallel to the line. So B, I can label this as B, I minus 2j plus 2k, or you may write this in the column vector 1 minus 2 and 2. Next, in order to find the distance of the point from the line, I can draw here for your understanding. There is a straight line. Say this line is here. This line is here, and the point is point Q, and Q has the coordinates 1, comma 2, comma 3, and also the direction vector for this line is B. I can draw it here, just parallel to the line. Now, uh, the distance of the point from the line means the shortest distance of Q from the line. The shortest distance, for the shortest distance, I must draw a line which is, this dotted line is perpendicular. So this is the shortest distance of the point. So the distance of the point from the line means the shortest distance. So this angle is 90 degrees. So if we find the point Q, then you can apply the distance formula to obtain the distance of the point Q from the line. Let this point be P. So next we'll try to find the coordinates of P. How to find the coordinates of P? We follow this procedure that first as you're given the equation of line in the vector form, so you may write 3, 4, and minus 2 column vector plus t into 1 minus 2 into 2. And yes, we can write the parametric equations. So x is equals to 3 plus t, and y is equals to 4 minus 2t, and z is equals to minus 2 plus 2t. And we know that uh, these are the parametric equations, or you can say that the point, you can write in this way the general point on the straight line. Let this point is P, 4 minus 2t here, and minus 2. So this is actually the general point. This you can call as the general point on the line. But I'm looking for the point on the line which is closest to Q. So as this is the general point, so what procedure we follow, because this P point can be obtained if you find the value of T. So point is how to find that value of T, which can give you the point on the line which is closest to Q. So here, this procedure we follow, uh, you can find a vector QP. Next, find vector QP. This vector can be obtained by using this simple. You can write QP as OP minus OQ in terms of the position vectors. The points are given. So OP point is given in terms of T. So keep in mind that we are trying to find the value of T for which the point on the line is closest to the point Q. And yes, 1, comma 2, comma 1, 2, 3 is second. So you can simplify. And yes, if you simplify, simple, c plus t minus 1, this is 2 plus t. Then it is 2 minus 2t. Then it is 2t minus 5 when you simplify. So here we have the vector QP in terms of t. Now, using the fact that as the point is closest and this angle is 90 degree, so this vector QP is perpendicular to the line. So you can say that QP vector is perpendicular to the line. if this is perpendicular line and B vector is the direction vector for the line, so yes, you can write that QP is perpendicular to B. So QP vector is perpendicular to B because QP is perpendicular to the line and the line is parallel to, and line has the direction vector B. So QP is perpendicular to B. So therefore, I can write here that therefore QP here QP is perpendicular to vector B. We know that if the two vectors are perpendicular, their scalar product is 0. So as QP is perpendicular to B, so using that the scalar product or the dot product is equals to 0. This is for perpendicular vectors. This is for perpendicular vectors. Yes, we have the two vectors QP we just obtained in terms of T. So write 2 plus T and 2 minus 2T and 2T minus 5 dot B vector. Yes, B vector is the direction vector 1 minus 2 and 2, 1 minus 2 and 2. 1 minus 2 and 2 is equal to 0. The dot product is 0 because these are perpendicular. So next, what I can do, I can multiply the corresponding entries, and yes, scalar product formula is the scalar product of two vectors. 2 plus T, 2 plus T is multiplied by 1, 2 minus 2T is multiplied by, multiply the corresponding entries, and that component equals to 0. Simplify, and yes, from here you can find the value of T, and that value of T for which the point is on the line closest to the point Q. Plus 4T minus 10 is equal to 0. So we have 9T, then next we have 2 minus 4 and 4. So I can write plus 4, 1, 2, 3, 4, 5, 6. So I wrote one thing extra. Yeah, this is there, plus 4. Then 2 minus 12 is equals to 0. T is equals to 12 over 9. So T is equals to 4 over 3. So this is the value of T for which you can obtain the point. So after finding this value of T, we have two options. Either we find the coordinates of P from here, or you just simply find the vector QP and find its magnitude. So therefore, QP vector was 2 plus T, 2 minus 2T, 2 plus T, 2 minus 2T, and finally 2T minus 5. 2T minus 5. So using the value of T here, 2 plus 4 over 3, 2 minus 8 over 3, and the last is 8 over 3 minus 5. So QP vector in this way is 10 over 3 minus 2 upon 3 minus 7 up. So this is the vector QP. So if you know the vector QP, QP means this vector which is shown dotted here. So this vector is there, vector QP. And obviously the magnitude of this vector would be the distance between the points P and Q, or the distance of the point from the line. So let's find the magnitude. We know the formula for the magnitude. Magnitude is find magnitude QP, which will be the distance. 10 over 3 whole square minus 2 over 3 whole square minus 7 over 3 whole square magnitude. So we have the first one is 100 over 100 over 9, 4 over 9, 49 over 9, which simplifies to 153 over 9. And next is 9 ones are 9 7. So root 7. So the distance, so the magnitude of QP vector is here, which is the distance of the point from the line. So we can, if I label this as D, the distance of the point from the line D is equals to question mark. So the distance of the point from the line is root 17. So yes, this distance was question mark, the distance of the point from the line. So hence, therefore D is equals to root 17 units, which is the distance of the given point from the given line. And this is the procedure for finding the distance of the point from the line. Thank you.